Hello. This is the final video of ENPM809t. Our professor was Dr. Mitchell, who was fabulous. We had a lot of fun, and we were supposed to make a mini Mars rover, and this is how I made mine. Now I'm gonna show you all the parts of the robot. This one is the Raspberry Pi. This is the microcontroller that I use to control my robot. I installed Python in it and the whole coding is done on Python. Here you can see the wheels and the brushless DC motors, which are 5 volts. We have 4 of these, and in the front left and the right back one we have connected 2 encoders to keep in check of the rotation of the motors. Here is the setup for a DC motor using the encoders. Here we can see Hall effect sensors and the metal part at the top. So as the metal part rotates, the magnetic field is changed, of which the Hall effect sensor keep tracks of and gives us the encoder counts or ticks. This is the edge bridge, aka the transistor, which keeps in check of the interface between the motors and the Raspberry Pi. Here we have an end effector which opens and closes to pick up the blocks, and it is controlled by a servo motor which is connected at the bottom. This is an example of how the end effector was opening and closing using the servo motors and the percentage of duty cycles at different positions of the end effector. This is the camera module that is located at the front of the robot. I used it to detect blocks. We were given sonar sensors to detect the blocks, but it was not working out for me. So I used the camera detection to detect blocks, and it worked out pretty fine. These are some of the sample images that I used to calibrate my HSV values for the bot. The traffic light that you see was given as an assignment in the class so that we can know how everything works. As you can see in the bottom left picture, I have taken an account of all the blocks because sometimes what happened is I was going for the red block and it was detecting yellow. In the hue saturation values, it is pretty close, so you need to have all the blocks in account and then do the HSV evaluation. I also use these plastic protectors at the front so that when the bot is moving, while holding some other block at front, the other blocks can just come here and then go past by the robot and not get stuck here at this point. robots are set up, you can see that at the bottom there is the initial or the landing point, and it has to collect all the blocks from the cluttered environment and drop it in the construction zone, which is of 4 by 4 feet. This is just a vague diagram that I made to calculate the turning angle when the block is picked up by the robot. It is between the cluttered environment and the construction zone. In the end, I would like to say that being a robotics graduate student in University of Maryland, I never got to put my hands on any robots, and this course actually helped me in doing so. So now I know how the robotics software and hardware, both components, how to make them work together. And this course is perfect for that.